In Algebra 2, Section 3.1, we're going into systems of equations. So Chapter 3 has a lot of systems of equations. What that means is we're dealing with not just one equation, but we're dealing with two. So a system of equations has two or more, but their solutions are the same. For example, when we're solving x minus 2y equals 0, x and y represents a number, right? But when we have a system, that means we have two equations, x plus y equals 6, which is another equation, but this x and y and this x and y are the same. We have to find out what number is the same, or what point, x and y point, can work for both of them. Okay, and there's several ways to do it. For this section, we're going to learn how to do it algebraically. With using graphs, and then next section we're going to do it algebraically. So, for example, we have, let's do this one, and I'll walk you through, and then we'll do an example together. So, let's graph each equation. So I'm going to graph this one first. X minus 2y equals 0. Okay? So, we want to make it into the y equals mx plus b. So I'm going to subtract x on both sides, and negative 2y equals negative x, and then I'm going to divide both sides by negative 2. So what I'm doing is I'm putting it into the y equals mx plus b format so that I can graph it. Okay? So I end up, these cancel out, I end up with y equals, this negative cancels out, 1/2, because the number in front of the x is 1, half x. And there's no b. Okay? What that means is if there's no b, that means it's plus 0. So that means I'm going to start at 0, and then since it's positive 1/2, I'm going to go up 1 over 2. Up 1 over 2. And this right here is my first line. Okay? And usually you would do this in graph paper so you can be more exact, because in this case I can't really be that exact because I make my lines. So let's try the next one. Next one is x plus 6y. So x plus y equals 6. So I'm going to take the x and put it on the other side. I'm going to do y equals, I'm going to put the x in front, negative x, this is plus 6. So that means I'm going to start at 6, 3, 4, 5, 6, on the y-intercept because this is my b, and I'm going to go down 1, over 1, down 1, over 1, down 1, over 1, okay? And this, and down 1, over 1, and then down 1, over 1. So this one right here, this is a very important point. This is my solution. This is my answer. So that means in both of these equations, all these points work for just this line, and all these points work for just this line. But the point where they intersect means they share this point. That means this x and y, which is 1, 2, 3, 4, up to 4, comma 2, where they intersect right here is where both of these share. So that means this equation, if I plug it into both, makes both of these equations true. So that's what we're looking for. We're looking for a solution, okay, where if a point where if I plug it into this, it makes this whole thing true, and if I plug it into this, it makes this whole thing true. For example, this is 4, okay, this is x and this is y. So 4 minus 2 times 2 equals 0. Well, this is 4, 2 times 2, negative 2 times positive 2 is negative 4 equals 0, 0 equals 0. Check. My next one is x is 4 plus 2 equals 6. 4 plus 2 is 6 equals 6. Check. So this and this is how I use to check it. Alright? So one more time, I'm trying to find where they intersect. essentially all this work that I have to do is in color, but the brown is showing you that this point works for this equation right here and for this equation. So you're ultimately looking for the one point that makes both equations true at the same time with the same x and y. So don't forget your vocabulary words. We're going to go ahead and go into examples. Pause this and write down what I have. Alright, so we're going to do a very similar thing here. We're going to do x minus y equals 5, x plus 2y equals negative 4. So the first one, I'm going to take this equation, x minus y equals 5. And again, I want it in what form? Y equals mx plus b. Okay? I'm going to put it in a different color because I think some of you guys have a hard time seeing this in green. So we are doing y equals mx plus b. That's the format we want to do it. M is my slope and b is my starting point, my y-intercept. Okay? So x minus y equals 5. So I'm going to start by subtracting x from both sides. I end up with negative y equals negative x plus 5. Now, this negative can't stay there. So I'm going to change the sign by dividing everything by negative. Okay? Making this y equals, this negative cancels out, giving me positive x. This changes it to negative 5. So, how do I graph this? Well, I'm going to start with negative 5. 1, 2, 3, 4, 5. And I'm going to go up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Okay? Try the next one. This is x plus 2y equals negative 4. I'm going to subtract both sides by x. I end up with 2y equals negative x minus 4. Then I'm going to divide this by 2, and remember when I divide each term. So I end up with y and 2, so it's negative 1 over 2x, and then negative 4 divided by 2 is negative 2. So I'm going to start at negative 2, and then this is a negative slope. I'm going to go negative 1 over 2. Okay, negative 1 over 2. So this point right here is my solution. It's where they intersect. Okay, which is negative 1, 2, 3 over 2. So alright, so one last thing though, when I have something like this or like this, when I subtract, for example, if I do 2 y equals negative x minus 4, if I divide this by 2 and I divide this by 2, then I cancel this out and this becomes y. This 2 right here has to be put in under here and underneath. Remember, you have to divide it by every term. So a term is divided by an equal sign, a plus sign, or a negative sign. So make sure that you include that. And that's how I got negative 1/2, because the number from the x is a 1. So it's negative 1 over 2 minus y. When it's supposed to be 4, actually, not y. Alright, so once I have this, I'm going to graph negative 3, 2. It's pretty straightforward. It's better if you do it with graphing paper, so when we do it in class, I'm going to try to pass out graphing paper so you can be more exact, because the lines might not be exact. Go ahead and try page 120, number 4, page 120, number 4, and then bring it to class tomorrow. That'll be your only problem.